All right, guys, today we are going to go over how to differentiate between ionic and covalent rules for names and formulas. This is something that can often be tricky. If you're not sure about how to name ionic or covalent independently, please check out my other videos that are linked above, in which I go through all of the rules for just ionic compounds and all of the rules for just covalent compounds. This video is going to help you differentiate when to use which rules and how to know which system of naming to use. So the first thing we have to understand about ionic and covalent compounds is what they are made of. Ionic compounds are made of a metal and a nonmetal. Covalent compounds are made of two nonmetals. So we need to be able to identify what are considered metals and what are considered nonmetals on the periodic table. In order to determine which are metals and which are nonmetals, I'm going to focus on this staircase line. This staircase line is my dividing line. Everything to the right of this is considered a nonmetal. So I am going to find two nonmetals in my covalent compounds. So I might see nitrogen and sulfur, or oxygen and chlorine. Those will be the only types of elements present when it is covalent. Now, if I have an ionic compound, it will always be comprised of a metal and a nonmetal. The metals are found to the right of the staircase. These are all metals. It's important to note that these middle ones are called transition metals, because we will have to identify those transition metals when we are naming ionic compounds. The transition metals are found in this middle section here. But whenever we have any metal, transition or not, and a nonmetal, we will have an ionic compound. When we have a list of names that are mixed with ionic and covalent, it's important to always start this process by identifying which are metals and which are nonmetals. We'll do a few together using the periodic table. Our first compound is calcium chloride. I'm going to find calcium on the periodic table, and I'm going to find chlorine on the periodic table. Calcium is in the metal section, and chlorine is in the nonmetal section. That means that we are going to have an ionic compound that forms between the calcium and the chlorine. I like to start by identifying if it is ionic or covalent and not even worry about the formula writing piece of it yet. Let's go ahead and look at the next one. We have phosphorus and hydride. Hydride means that we have the element hydrogen. When I find phosphorus on the periodic table, phosphorus is a nonmetal. Hydrogen is the only nonmetal that is located to the left of the staircase. So this is an important exception to our rule, which is why we're including it. So P is a nonmetal, and H is a nonmetal as well. If I have two nonmetals, I know this is going to be a covalent compound. In order to indicate that, I'm going to put an N above to indicate that they're nonmetals, and a C here because I know it's going to be covalent. Let's look at another example. My first element here is iron. The second is nitrate. I notice that this has an ATE ending instead of an IDE ending. When I see that ATE ending, it's going to be an immediate sign that I have a polyatomic ion. But let's start and see if we can figure out if this is going to be ionic or covalent by first referring to the periodic table. Notice that iron is right here. It's in that transition metal section. What we're going to notice is that every time we have a transition metal, we are going to need a Roman numeral to indicate the charge of the transition metal. Iron is a metal. Remember that Roman numeral is an important part of an ionic formula, and then nitrate is made of all nonmetals. As soon as you see you have a polyatomic ion in your formula, you know that it is going to be an ionic compound as well. I'm going to continue identifying if the rest of these are metals or nonmetals. All right, so now I have them identified as ionic or covalent. I suggest when you're first starting these mixed naming problems and mixed formulas, I would start with just one type. So identify which ones are covalent, and let's do the covalent first because most people find those a little bit easier. When you have two nonmetals and a covalent compound, the prefixes are going to indicate how many of each atom you have. Phosphorus is the element P. So I'm going to write the element symbol P, And notice that there's no prefix on this. If there's no prefix on the first element, that indicates that there's only one of them present in the compound. Hydride comes from hydrogen. So I'm going to write this symbol H, and the tri tells me that I have 3 of those hydrogens. I'm going to indicate the number of atoms by writing a subscript underneath. I don't have to write a 1 because it's assumed that if I took the time to write the element, there's one of them there. Let's jump to my next covalent. My next covalent is down here. So again, 2 nonmetals. I am going to determine what element I have. Nitrogen, when I go to the periodic table, is N, and the die out front indicates that I have 2 nitrogens. I'm going to show that with a subscript in order to tell how many there are. Tetrafluoride. I'm going to look at the element. Fluoride comes from fluorine. The endings are always going to change to IDEs on these. So the root of the word is what you want to look for. Fluorine is the element. And tetra indicates that I have 4 of them. So the formula for this would be N2F4. Let's take a look at some of the ionic compounds now. When we have an ionic compound, remember we have a metal and a nonmetal. Metals have a low electronegativity and nonmetals have a really high electronegativity. So they're essentially playing tug of war for the electrons, and in an ionic compound, the metal is going to lose its electron, which means it'll end up with a positive charge, and the nonmetal is going to gain the electron and end up with a negative charge. But there can be no missing electrons in this process, so the overall charge of our ionic compound always has to add up to 0. Keeping that in mind, when we have ionic compounds, we have to be comfortable with the charges that elements have when they're in a compound. So let's go back to the periodic table and indicate their charges in the columns above them. Everything in group 1 is going to have a +1 charge when it's stable. That means it's going to lose 1 electron to be stable. This group needs to lose 2 electrons to be stable, so it'll have a +2 charge. These transition metals, we don't know what their charge is. They can have multiple different oxidation numbers. So this whole middle section we're going to skip over. This column is going to be +3. Once we hit the carbon column, we can have plus or -4. Nitrogen's column is -3. Oxygen's whole column is -2. -1 for fluorine's column, or the halogens. And the noble gases are going to be 0 because they don't gain or lose any electrons. They are already happy as is with their 8 valence. So when we have an ionic compound, you always want to start by identifying the element symbol and the charge. Calcium is Ca, and it has a +2 charge according to what we just labeled on the periodic table. Chlorine is Cl with a -1 charge. Again, I'm using those charges that we just labeled on the periodic table. Now, this is telling me that calcium needs to lose 2 electrons and chlorine needs to gain 1. They cannot make each other happy or stable because there can be no leftover electrons. The easiest way to approach this is mathematically. You want to find the lowest common multiple between the 2 charges. 2 and 1 fit evenly into 2. So what I'm going to do is determine what I need to multiply my calcium by to make it a +2. I only need 1 of them, so I'm going to write just 1. I don't need to indicate that there's a 1 with a subscript because it's assumed that if I took the time to write it, there's only 1 present. In order to get this to -2, I'm going to have to multiply it by 2. That means I need 2 chlorines. I'm going to show that by putting a subscripted 2 below. It's important to remember that superscripts indicate the charge and subscripts tell you how many atoms you have. Let's take a look at another ionic example. I've already determined this is ionic. When it's ionic, I know I have to deal with charges. I'm going to start by writing the element symbol, Fe, and the charge. Now, when I go to the periodic table, iron is in that middle section. That means that we can't tell its charge from the location on the periodic table. Instead, we're going to have to look at our Roman numerals here. Our Roman numerals are going to tell us the charge of a single iron atom. In this particular compound, iron has a +2 charge. Then I'm going to look at nitrate. Nitrate is a polyatomic ion, so you're going to look at your polyatomic ion list. When you have a polyatomic ion, you're going to treat it the same. You're going to write the symbol, and nitrate is NO3, and it carries a -1 charge. So now this is just like the last example. Even though I have NO3 with a -1 charge, I'm still going to zero out my charges the same as I did before. 2 and 1 fit evenly into 2. So I need to figure out what I have to multiply my iron by to get a +2 charge, and I only need one of them. Then I am going to have to multiply by my NO3 by 2 in order to get a -2 charge. So I'm going to write NO3, and I need 2 of them. Now, whenever I have a polyatomic ion, it's important that if there's more than one polyatomic ion present, we put a parentheses there. That parentheses tells me that there's 2 of the entire NO3 group. If I don't have the parentheses there, you're going to know it because it's going to look like you have 32 oxygens. All right, let's look at another example. Aluminum sulfate. I've already identified that it's ionic, and if it's ionic, I need to pay attention to the charges. Aluminum is Al, and according to how we label the periodic table, aluminum will be a +3 charge. As soon as I see this ATE ending, that indicates that I need to look at my polyatomic list. Sulfate is SO4 with a -2 charge. Always start by writing your element symbol and writing your charge. Notice as well that we always put the positive first whenever we write an ionic formula or name. Once I've identified the charges of each atom, I now need to figure out the lowest common multiple between them. What do they both fit evenly into? 3 and 2 fit evenly into 6. So I have to determine how many aluminums I need. In order to get this to a +6, I'm going to have to multiply my aluminum by 2, meaning that I need 2 of them. I'm going to show that with a subscript. My SO4, I'm going to need to multiply this by 3 in order to get -6. So in order to show 3 of them, I'm going to write SO4. And again, I don't want to just put the 3 there. It looks like I have 43 oxygens. Instead, I want 3 of the entire SO4 group. Our next ionic compound, again, has a Roman numeral, but don't let that scare you. That actually makes this process a little bit easier. We're going to start by putting down silver's symbol from the periodic table, which is Ag. Now, Ag is in the transition metal section, which means that I don't know the charge from its location on the table. Instead, this one here is going to tell me that silver is carrying a +1 charge. Phosphate, I see that ATE ending again. That tells me that I need to go to my polyatomic sheet. On your polyatomic sheet, you'll see that PO4 carries a -3 charge. After you've identified the charges, you now have to zero the compound out. In order to do that, we're going to figure out what 1 and 3 fit into evenly. The lowest common multiple between them is 3. I'm going to have to multiply my silver by 3. So I'll need 3 silvers. And I'm going to have to multiply my phosphate by just 1. That means that I only need 1 of them. Because there's only one of the polyatomic, you do not have to put that polyatomic in parentheses. Ag3PO4 is the correct formula. We have one more ionic to try together. This time I have potassium oxide. Again, I've already identified that it's ionic, so I know I'm going to need to start by writing the symbol and writing the charge. Oxide is O, and oxygen carries a -2 charge. Once you have the charge of each of the individual elements, you're going to find the lowest common multiple between them, which is 2. You're going to have to multiply your K by 2 in order to get 2 positives, and you're going to have to multiply your oxygen by just 1 in order to get 2 negatives. So K2O is the correct formula for potassium oxide. Let's look at what approach we're going to take when we're going from the formula now to the name. I would start by finding if you have metals or nonmetals and then classifying them as ionic or covalent accordingly. Mn is a metal. Oxygen is a nonmetal based on its location on the table. Metal and nonmetal again means ionic. K is a metal. Then I see NO3. When I have 2 or more elements in an ionic compound, that tells me that I have a polyatomic ion. So nitrogen and oxygen are both nonmetals. I'm going to label this as ionic. I'm going to go through and classify the rest as metals or nonmetals. All right, now that I've identified whether I have metals or nonmetals, I am going to classify them as ionic or covalent. This one is covalent, metal and 2 nonmetals, again ionic, metal and nonmetal ionic, 2 nonmetals covalent, metal and nonmetal ionic. Let's start again with one system of naming. This time we'll start with the ionics. So we'll do all of the ionics first, and then we'll go back and do the covalents. I would suggest taking this approach until you get really confident with your naming rules. When we have an ionic compound, we're going to write the name of the first element. My first element is manganese. Next, I'm going to go to the periodic table and I'm going to determine if manganese needs Roman numerals. When I find manganese on the periodic table, manganese is in the transition metal section and I don't know what its charge is based solely on location. So I am going to need Roman numerals here. If we need Roman numerals, I like to leave a place for the Roman numerals and then come back and figure out what Roman numeral I'm going to use after I finish naming the rest. So oxygen becomes oxide. We change the ending to IDE. Now I need to determine what is the charge of the manganese. Remember that every ionic compound has to add up to 0 every time. I don't know the charge of the Mn, but I do know that oxygen has a -2 charge and there are 2 oxygens here in this compound. That means that altogether I have 4 negatives. And if my compound has to add up to 0, which every ionic compound does, that means that I'm going to need 4 positives in order to balance it out. My Mn is then carrying a +4 charge. I'm going to show that with a Roman numeral 4. If you're not familiar with the Roman numerals, this is 1 through 6 in numeric order. So if you need a refresher on Roman numerals, you can use that as a reference. All right, our next ionic compound is KNO3. We're going to start it the exact same way. K is potassium, so I'm going to copy its name right off the periodic table. Then I'm going to identify if I need Roman numerals or not. Because potassium is located right here, I know for certain its charge is +1, and if I know its charge, there's no need to include Roman numerals. I only need Roman numerals when I have something that has multiple oxidation numbers from the transition metal section. Since I don't need Roman numerals, I'm just going to keep right on going. Now, if I see that I have more than 2 elements left after I've named the metal, I know I need my polyatomic sheet. So I'm going to go to my polyatomic sheet and I'm going to find NO3. When I find NO3, it tells me that NO3 is called nitrate. I'm going to copy that exactly as I see it from my polyatomic sheet. I'm going to skip this covalent one for right now. We'll come back to that later. And let's look at our ionic compound. I'm going to name the metal. The metal is iron. And then I need to determine if iron needs Roman numerals. Since iron is found in the transition metals section of the periodic table, I'm going to leave a space for my Roman numerals and I'm going to continue naming. Here, I have more than 2 elements remaining after the metal. That again indicates that I'm going to need to go to my polyatomic sheet. My polyatomic sheet tells me that SO4 is sulfate. I need to figure out the charge of the iron. The only way to do that again is to understand that my ionic compounds have an overall charge of 0. My polyatomic ion sheet tells me that sulfate has a -2 charge, but notice that there are 3 sulfates, which means that altogether I have 6 negatives in this compound. My ionic compounds must always add up to 0. So if they always add up to 0, I need 6 positives to balance out those 6 negatives. But I'm not looking for the total number of positive charges from the metal. Instead, I'm looking for the charge of a single iron. Yes, there are 6 positives in this compound, but they are split between 2 different iron atoms, which means that each iron atom has a +3 charge. So I'm going to put a Roman numeral 3 there. Iron 3 sulfate is the name of that ionic compound. Let's take a look at another one. Metal and non-metal indicates that it's ionic, so I'm going to name the first element, which is sodium. When I find sodium on the periodic table, it is not in the transition metal section, which means that I do not need to include Roman numerals. Instead, I'm just going to keep right on going, and I'm going to name my chlorine. Chlorine becomes chloride. Every time you have an ionic compound, you're going to change the ending of the second element to IDE, unless you are writing a polyatomic ion, in which case you just copy it exactly as it's listed. My next example is covalent, so we're going to skip that for now, and we're going to jump down to our last ionic compound. I'm going to start by naming the first element, which is nickel. When I go to the periodic table, I see that nickel is a transition metal, and because it's a transition metal, I do need to include Roman numerals to show the charge of the nickel. I'm going to leave a space for that and come back to it. And P is my nonmetal. P is phosphorus, but I'm going to change the ending to phosphide. Now I need to figure out the charge of the nickel. My overall compound, again, has to add up to 0. And when I look at the periodic table, I know for certain, based on location, that P is in a column that carries a -3 charge. Since P is -3 and I want this thing to add up to 0, I'm going to need a +3 charge on the nickel. And since there's only one nickel here, that one nickel is carrying a +3 charge. The Roman numeral should indicate the charge of a single nickel atom, which this does, so nickel 3 phosphide. The more you practice these, the easier they become, but this is one of those skills in chemistry that is going to keep resurfacing throughout the year. The more familiar you get with these ionic compounds, the better off you'll be. Let's tackle those covalent compounds next. The good news is my covalent compounds are a whole lot easier. Because there's 2 nonmetals in a covalent compound, there are no charges at all. So my covalent compounds, I'm just going to use prefixes to tell how many. Here there's only 1 carbon. We do not use the prefix mono on the first element, so I'm going to name the first element just carbon. Then there are 4 chlorines. The prefix for 4 is tetra. If you're not sure about the covalent prefixes, please check out my earlier video in which we run through all of the Greek prefixes. Chlorine, rather than writing chlorine, we always change the ending of the second element to IDE, so it becomes chloride. Again, when it's covalent, there are no charges. So since there's only 1 carbon here, I am going to write carbon. There's no need to use the prefix mono on the first element. But when I get to my oxygen, notice that there's only 1 oxygen as well. We do use mono on the second. So this becomes carbon monoxide. All right, let's do a really quick recap here in order to help differentiate between our ionic rules and our covalent rules. If we have an ionic compound, we are going to know it's an ionic compound because it contains a metal and a nonmetal. If you have an ionic compound, you will need to worry about the charges of your metal and nonmetal, and remember that the overall charge of the compound must always add up to 0. If it is covalent, you will know that because there are 2 nonmetals. When you have 2 nonmetals in a covalent compound, you are never, ever, ever going to have charges. Instead, you are going to use prefixes to tell how many atoms you have. We never, ever, ever use prefixes on an ionic compound. We only use prefixes for our covalent compounds. I hope that helps clear up how to name and write ionic and covalent names and formulas. Thanks for watching, and we'll see you guys soon.